8th graders and algebra students all over the world. Thank you for watching. This is section 2.2. We're doing multi-step inequalities. We've been doing one-step and two-step inequalities, and we're just getting a little bit deeper. We're digging deeper into this. All right, let's take a look. Solving inequalities, when you start getting into multi-step, you want to look for a couple of situations. You want to look for a distributive property that may pop up. You may want to look for combining like terms. That may come up where you have some terms on the same side that you could actually combine and simplify and make that look a little bit more simple. Let's look at the first problem together. It says -4 plus -8 is less than -5c minus 2. Now, in this case, did you notice that there are parentheses around the -8? Sometimes the publishers of your book and sometimes different folks, to separate out a negative number, they'll put parentheses around it, okay? It really doesn't mean anything other than draw your eye to the fact that this is indeed a negative number. That's really all it's there for. Those parentheses do not indicate a distributive situation, so you don't need to worry about that. Okay, now let's look at what we do have. On the left side, we have like terms. This is a great opportunity to go ahead and clean that up and make it one number. They are like terms. So what's -4 plus -8? That's right, -12. Okay. Now, from here, there's no distributive situation, never was. We did combine some like terms on the left. There aren't any like terms on the right. So really, from here, it's just a two-step inequality that we need to solve. So we want to protect that C term right now, just leave it where it is, and let's move the -2. How do you undo subtraction? That's right, we're going to add 2 to each side, okay? Now I'm going to bump into this next problem, so I'm going to move it up here over to the right, and I'm going to get -10, because -12 plus 2 is -10, is less than -5c, okay? So remember that rule we learned in 2.3, it doesn't apply to addition and subtraction. So really, I haven't really done anything yet that would cause my interest to peak as far as that is concerned using the rule. All right, now I'm going to get interested, because now to get c by itself, I've got to divide each side with a -5. Because I just moved a negative number over by means of division, I'm going to have to flip my less than symbol to greater than, and then I'm done. So you can leave your answers 2 is greater than c, or if you want to flip it over and write it as c is less than 2, you can do that as well, okay? So that's the first one there. Let's look at the second one. Remember, in multi-step inequalities and equations, you're looking for a couple scenarios. Do you see a distributive situation? Do you see any place where you could combine like terms? So we're looking for those types of situations. And we do see a pretty interesting situation here. On the left, you are distributing a -3 to the quantity there. So let's do that. -3 times +3 is -9. And then -3 times -x is +3x. Yes, both these numbers, the 3 out here is negative, and the x, that minus sign, is the sign of the x as well. So they're both negative, so negative times a negative is a positive. All right, so that's the left side. They're not like terms, so I'm really as simplified as I can get. So I'm going to drop down the less than. This is really interesting. You have 4 squared. Basically, they're just asking you, what's 4 times 4? That's what an exponent is. It just tells you how many times to multiply that base to itself. So we're going to multiply 4 to itself. That's it. 4 times 4 is 16. So that's all the simplifying I could do on the right. Now from here, it's just a regular old two-step equation or inequality. We're going to isolate the x term. We're going to get it by itself. So we're not going to really worry about the 3 right now. We're going to move that negative 9 over. Notice that negative 9 is being added to 3x, and negative 9, of course, is negative. So to undo the negative 9, we're going to add 9 to each side. Okay? And we're going to get 3x is less than 25. And then we're going to divide each side by 3. Now, I wasn't real concerned about using the rule because 3 was positive. So I noticed it, but it only really registers with me if it's negative. So you can leave your answer in improper fraction form as long as it's reduced. You can change it to a mixed number. You can change it to its decimal form. Whatever makes you happy makes me happy, okay? Be ready to do any of that on a multiple choice test. It just depends on how they present the answer on a multiple choice test. All right, let's take a look. We've got 4/5 x plus 1/2 is greater than 3/5. You can solve it using your fractions there if you want to. If you're like, hey, I like fractions, I'm going to solve it just like that, that's fine. If you're like me and you're like, well, I'm okay with fractions, I'm not bad at them, I just don't really prefer them, then let's convert and let's just rename the problem so that they all have the same denominator. Okay, so our 3 choices in denominators are 5, 2, and 5. If I wanted a common denominator, and I do, what would be my common denominator? If you're saying 10, you are right. Okay, so we're going to turn everything into tenths. Okay, all right, 5 times, what is 10? 2. 2 times 4 is 8. So 4/5 is the same thing as 8 tenths. 2 times 5 is 10. 5 times 1 is 5. 1/2 is the same as 5 tenths. And 3/5, 5 times 2 is 10. 2 times 3 is 6. So 3/5 is 6 tenths. Now remember the cute little shortcut I showed you? We're just going to kind of mark out those denominators, and we're going to work with this equation. 8x plus 5 is greater than 6. So that's what we're going to work with today. And, you know, it may not be a perfect number, a whole number, but don't let that bother you. Just do the best you can with it, okay? So this is a typical 2-step equation. So we're going to get the x term by itself and leave the 8x there. Just ignore it for right now. We need to isolate that whole term before we can move 8. We really got to move that 5, okay? So let's move the 5 over. So we're going to subtract 5 from each side, and then we're going to divide by 8. So it's a typical 2-step inequality. Now I didn't really need to use my rule because none of my numbers were negative, so I wasn't really concerned about that at all. Usually I don't get too upset or concerned about it unless the number that's multiplied to my variable is negative, or the number that my variable divided by that number, a number, is negative. That's really the only time I get concerned about it. Okay? So that's example 2. Just showed you a couple of ways to deal with multi-step inequalities. Bring your questions to class and be ready to practice this concept. Thanks for listening.